Hello students and welcome back. So now we are going to talk about one interesting feature that we have in Verilog programming, and that is conditional statements. So in this video we are going to talk about conditional statements, and that is nothing but if-else statements. We are going to see how can we use only if statement, if-else statement using single as well as multiple statements. So let us get started. So conditional statements are used to decide the action in different situations whenever they arrive. So I have to make a decision that if the signal value is 1, what should I do? And if it is 0, then what should I do? So if statement is used to describe the statements. In these cases, if I have a very simple logic that I am just checking the sensor value, and if the sensor value is high, that means true, then do this. So this is the simplest logic that we can have in the conditional statements. And then I say, okay, if it is not true, then what should I do? Then we describe those actions also. So this is how the conditional statements works. The simplest one is if. If the expression evaluated is true, I am saying I am looking at a sensor value and that is true. Then I write a set of statements that if it is true, then do these. So we will write a block and there we will write the set of statements. If our condition is false, the statements written inside that if block will not be executed. The compiler will not execute those lines of codes. If there is an else statement which is complemented with if, then we can write those actions also, that if the statement is not true, then go to else and execute these statements now. So syntax is simple. I will write if, and inside the brackets we will write the condition that need to be evaluated. If sensor value equal to 1, or if temperature less than 35, anything. If you have to perform only single statement, just write the statement. If we have to use multiple statements, then we will write begin and end while writing those multiple statements. Normally, the if alone may not be sufficient, so we use the combination of if and else. So we will write the condition of if, then the expression. So if the temperature is less than 35, we will begin and end the statements, and then we say else, and then we will begin and end the statements which will fall under the false condition, that means else condition. If else can also have else if, that means multiple comparisons. If the temperature is less than 35, do this. If it is between 35 and 45, do this. If it is between 45 and 65, do this. Else, do this. So that kind of things can be done using else if. So first I evaluate first condition, if expression 1, do this. Else if, check for expression 2, if that is true, do that. And else, that means all the above expressions are false, then do this. So these are the different methods that we use for conditional statements. And now let us go to Vivado and cross-check some of them. We are going to talk about if-else statement using one example of multiplexer. We have not studied multiplexer. We are going to do that in our next module, but let us focus on the coding part right now. So here we have mux 2x1, that is my module. There are 3 inputs, I0, I1 and S, and there is one output which is Y. The logic is if S is equal to 1, or we say if S is true, then Y is equal to I1. Otherwise, output Y is equal to I0. So a simple if else statement should do our work. So let us code it now. So first of all, we say always at the rate. We will mention the variables which are our input variables and are going to be used in the if else statement. We are going to use I0, we are going to use I1 also, and S. All three are going to be used. Then after always, we begin the always block and we say end. One thing which I have done by mistake here, this should remain here. Okay, so after the variable declaration we have the always begin and end. Now inside this always, that means whatever we write, it will always keep on happening. And what should happen? We have to compare. So we say if and simply say S. It will evaluate if S is true. That means if S is equal to 1. We have only single statement. We don't need to write begin and end. And we say Y is equal to I1. Else, in else also we have a single statement and we write Y equal to I0. So this is the code that we have as of now. There is a warning coming here. Okay, it is saying procedural assignment to a non-register. Now, whenever we are doing procedural assignments, we had talked about that it should be for the register. So the output variable, we have to explicitly mention that it is of the type reg register. And as soon as I write it, this error has gone, that warning has gone. And now we save it. So please remember, in procedural assignment, whenever you are going to use, always use registers. So there is no error here. When we talk about the schematic, we can generate that from the RTL analysis. The schematic is ready here, and we can see that when S is 1, then I1 is connected, and in the default case, that means else, I0 is connected to the output Y. Now let us cross check the functionality using the simulation as well. The simulations are ready. Now we will focus on S. When S is 0 up to this point, then whatever is the value of I0, 0, 1, 0, 1, same is given to Y. And when S is equal to 1, whatever is the value of I1, 0, 0, 1, 1, that is allocated to Y. So this is how the if else statement is working for the implementation of a 2x1 multiplexer. So students, now we have a good idea about conditional statements. In the next video, we are going to talk about a similar kind of statements, and that is called case statements. Keep learning. Thank you.